today, guys. For this video, I will show you how to prove the mean and variance of an exponential distribution. But before that, make I first sharply explain what an exponential distribution mean. A continuous random variable x is said to follow an exponential distribution if its PDF is function of x equals lambda exponential minus lambda x. Of course, because then are continuous, x go dey on interval. So we get x greater than or equals to 0 or minus infinity less than x less than positive infinity. 0 or 0 otherwise. So an exponential distribution models how long you have to wait between random events. For example, you dey bus terminal, you wan enter bus. You dey model how long you have to wait between bus wey don go and the bus wey dey come. Second example na call center. You dey model time between consecutive calls, that is between customer A, the time wey customer A end the call and the time wey customer B go call. You dey model the time, how long the time be. So to prove the mean, of course, na formula for mean for continuous. So formula for mean for continuous random variable x, it is expectation of x equals integral minus infinity to infinity x times function of x dx. So how we go estimate this, or how we go find our mean from this? We don't know the function of x, so plug into the formula. Minus infinity to infinity x times what's our function of x? Lambda exponential minus lambda x dx. Of course, lambda na constant, e no be s now. Carry that na comot. Lambda into bracket integral minus infinity to infinity x times exponential minus lambda x dx. So to find this integral, you have to use a formula called integration by parts. So using integration by parts, the formula na integral u dv equals uv minus integral 0 to infinity integral v du. So make we take this as integral u dv. So make we take this one as integral. So we wan estimate, we wan find our u, v and du. Let u equals x, u equals x, v equals dv equals exponential minus lambda x dx. So to get u from this dv, you gats integrate with respect to x, and if you integrate an exponential, the coefficient of what you are integrating with respect to will have to come down. So you get something like this: minus exponential. So our v here will now be minus exponential minus lambda x over the coefficient of our x, lambda. So integration sign, the x go comot like that. So we now get u, we now get our v, so we need our du. So from u equals x, differentiating u here, differentiate with respect to x. You know, when u equals x, you differentiate u, it will give you 1. That is du dx equals 1. So our du cross multiply equals dx. So after that one like that, make we sharply plug everything inside. So we have lambda into, we don't turn this one like this into u, wetin be u, x times wetin be v, minus exponential minus lambda x over lambda, ba minus integral 0 to infinity. No forget o, this one go get limit o, because you don integrate am like that. Wetin be v? Minus exponential minus lambda x over lambda, and our u, our du is dx, close bracket like that. So we have lambda x, okay, put minus of front like this, exponential minus lambda x over lambda is 0 to infinity, ba. So minus dey come outside, we go carry minus 1 over lambda comot. So minus times this minus go give you plus integral minus infinity to infinity, 1 over lambda. That's what cancels the minus. Exponential minus lambda x dx. So that one don go like that. If you plug in our limit into this baba, but before plugging the limit, something dey common. Wetin dey common? 1 over lambda. So lambda times 1 over lambda minus exponential minus x exponential minus lambda x is 0 to infinity plus integral 0 to infinity exponential minus lambda x dx. Check gap. So now I go cancel my lambda like this. We are left with this whole thing. Plugging this our limit into this one, we have infinity first minus, we send that to x exponential minus lambda infinity, ba minus x na 0 times exponential minus lambda raised to power 0 minus lambda times 0 close bracket plus, don't forget we still get this one. Say make we integrate am first, make we first write am 0 to infinity exponential minus lambda x dx. So automatically infinity times this one go give you 0 plus 0 times all this one go give you 0. So this all that one don turn to 0 plus integrating this one, normal integration now. If you integrate exponential, coefficient of x wey dey there go come down, minus exponential minus lambda x minus over lambda. Put the limit is 0 to infinity, ba. So after that one like that, plug in the limit wey dey here. Infinity first, infinity na greater than 0 now. Infinity minus exponential minus lambda times infinity over lambda minus, say this one get minus exponential, shey you get, minus lambda 0 over lambda. All this one automatically, this times this go give you, this times go give you 0. This times this will give you lambda infinity, and exponential raised power minus infinity go give you what? 0. So 0 over lambda 0, minus times minus plus exponential minus lambda times 0. Okay, minus lambda times 0 will give you exponential raised power 0, and anything raised power 0 na 1 over lambda. So therefore exponential x, which is mean, sorry I said exponential, expectation of x, which is our mean, equals 1 over lambda for an exponential distribution.